Hello students, I welcome you all to Brilliant Public School's online channel. Today we are going to discuss class 10th chapter number 2 which is polynomials. So let us start. Here we are going to discuss what is the definition of a polynomial, the zeros, the number of zeros, what is the standard form of a quadratic polynomial, even the relationships, and at last how to get a quadratic polynomials. So let us continue. Definition of a polynomial is very clear. It is an algebraic expression in one variable, and the power of the variables should always be a whole number, which you have very clearly studied in class 9th. Suppose I want to write a polynomial, so I will write px. X is the variable, and here suppose if I am writing 5x squared plus 6x plus 5. So this will be a quadratic polynomial, which is the area of concern in this chapter. Here you need to understand that the very first coefficient of x square, it can't be 0 if I want a quadratic polynomial. Also, you can very well understand the power of the variable as I have written. In the very first one, the power is 2. 6x, the power of x would be 1. And in the last one, there is a hidden x to the power 0. So all this 0, 1 and 2 belongs to the category of whole numbers. So in this manner, we can define a polynomial. Also, you can remember one more thing, that the power, it cannot be negative or in fraction. So if suppose somewhere you will find any polynomial which is written as x plus 1 upon x or something, because of this x in the denominator, you will not consider it as a polynomial. One more example I can give you. If you have root over x, that means more or less you have x to the power 1 by 2, which is half, a fraction. So this also we cannot consider as a polynomial. Number of zeros, or better I should say roots of the polynomial. Here you can see we have the graphical representation, we have a curve, and the sense what I can explain you, as many times the curve will touch x-axis, those all will be considered as the zero. So in this example you can see the curve is touching up 3 times your x-axis. Okay, so here I would be getting the number of zeros as 3 zeros. Okay, I would be getting 3 zeros for this curve. Let us see few more examples and then we will be able to find out how many roots or zeros are there. Here you can see it is a constant function, one degree 1, which is a linear function. For a quadratic function which we have discussed right now, the degree is 2 and the graph is also touching the x-axis 2 times. This is the first time and this is the second time. For cubic it will be 3, for a biquadratic function degree 4, and for a quintic function degree 5. So you can see the graph is touching up the x-axis 5 times. Okay, so in this manner we just observe the graph and we find out that how many zeros are there or how many roots are there for the given polynomial. This is the standard form of a quadratic polynomial. If it is equal to 0, I better say it is a quadratic equation. Here a, b, c are the constant values, and also you can say a is the coefficient of x square and b is the coefficient of x and c is the constant term. So any example, if I will write suppose 5x square plus 2x plus 6 is equal to 0, we will take it as a quadratic equation. Here in this one, we will find out the relationship between the coefficients of that standard form and the zeros. So here if I will write ax square plus bx plus c, this is the quadratic equation. And if I will say that I have this alpha and beta, are the two zeros of this quadratic equation. So in that condition, directly I can find the sum of these zeros, also the product of the zeros. Okay, so if I want to find the sum, I can directly take minus b upon a. And if I want the product of this, so I can directly take c upon a, where b is the coefficient of x and a is the coefficient of x square. You can see in this example over there. Also, if I want the product of the zeros, so in that condition, I can take the constant term. Also, I can take the coefficient of x square, which is a. So, sum is minus b upon a and the product of the zeros is c upon a. So, in this manner, we can find the relationship between the coefficients and the zeros. This is the last topic what is important for us, that if we want to make a quadratic polynomial. Okay, so a quadratic polynomial whose sum of the zeros and the product of the zeros what we have discussed right now is given to us. So here you can see this is the first root alpha and this is the second root beta. So if we will equate it with 0, it will become x minus alpha and x minus beta. We very well know the product of this x minus alpha and x minus beta will give us the quadratic equation. So after solving this, if we can take x common, it is as same as our identity. We are going to get this final statement that x square minus sum of roots whole into x plus product of roots equals to 0. So we have one question. If suppose the sum is equal to 4 and the product of zeros is equal to 1. So in that condition, if I will substitute in this, I would be getting x square minus sum of the roots, which is 4 into x, then plus the product of the roots, which is 1 equal to 0. So I would be able to frame a quadratic polynomial, that is x square minus 4x plus 1 equals to 0. So that will be the quadratic polynomial, and this is something we are going to discuss in this year's syllabus of polynomial. Thank you, students. Thank you for watching the video.